So in this class, we'll use a 5-step method to tackle hypothesis testing. And step 1 is setting up those hypotheses. So I'm going to do the easy one here with you, and then I'm going to have you guys try the harder two on your own. Of course, I'll go after them, but I want you guys to try them out before you just give my answers. So the first one, we have an accident rate of 12% from 2003, and we're interested in whether that true proportion having accidents has increased since 2003. So our null is going to be that it's still 12%. Nothing has changed, right? We always have, I can't emphasize this enough, we always have an equal to in our null hypothesis. And our alternative, still about P, still about that 12%, but now we're looking at that keyword of increased and realizing that that tells us that we want to say that P is now greater than 0.12. So we'd have a right-tailed test. So as I said, try out the next two and then watch, pause the video, see if you can do them. They get a little bit harder, so I want to see if you guys could do them on your own. So hopefully you paused and are coming back, because B is one where students get really confused. We have two different percents, and so students will get confused by this. Now, it shouldn't be this hard to keep them straight. When you have 2% in these hypothesis testing questions, one of them is going to be P hat, the thing we observed that gives us evidence towards our alternative, and one of them is going to be our P, which we actually will sometimes denote with a P a little zero, our claimed value. So this is our claimed value. This is our sample value that we're using as evidence. So in this particular situation, the 18.3 is in the same sentence as my 785 randomly selected students. So this is a P hat. This goes nowhere near hypotheses. And in fact, in the next piece, it says test the claim that the rate is less than this particular rate. So this is our claimed rate that we want to test. So our null is going to be that it is just equal to the 27 rate in the general population, and even says population here, our general population. And our alternative is that it is less than that 0.27. So that's how that one is a little more tricky. Again, that 18.3% is never going to show up anywhere in the hypotheses. It'll come in play in our second step. All right. And the last one, 7% of hospitalizations were for affective disorders. Suppose a sample this year of 1,000 hospitalizations of women in this age group showed 80 admitted for affective disorders. Does this indicate the proportion for affective disorders has changed since 2002? So we're looking here. We want to see if there's a change since 2002. So our 2002 value is going to be the one that we're testing, 0.07. And if we wanted to translate the rest of the stuff that was given here, they gave us a number of successes in our sample, which of course we could then use to go calculate a P hat, but we don't care about that for this particular piece. So we're going to go ahead and just set up our hypotheses. Our null is that P is equal to 7%. It's the same as it was in 2002. And our alternative is that it has changed. So change does not give us a direction. That's our first two-tailed test where we're looking at not equal to 0.07.